Hi, welcome to the Calculus 2 lecture series. And we are in this unit number 2. We talk about the different techniques of the integration. So this is our lecture number 8. We are doing the trigonometry substitution. This is the second video for this lecture. For the first lecture, for the first video, we covered your integrants, with a certain format, like if it's square roots of a squared minus x squared, or it's a squared plus x squared, then what type of the trig substitution you need to use. We went through all the three formulas, and then we kind of did the three problems to try to practice how to do the substitution. And for this video, we are going to continue do that. But now, after we did the substitution, then we're going to physically carry out the substitution. So it's another practice to get familiar with these techniques here. All right. So now let's go to our lecture notes here. Okay, so let's kind of refresh our memory a little bit. So those are the three things we talk about. We say this table is extremely important, right? So for the different things, how do you set, and then what is this red means? That means how do you define these numbers here? And then we did a three problems for our first video, just to show you how to do the substitution. And then we did not really carry out this integration. So now we have three more problems here, and for these three problems, we are going to physically carry out. All right, so the first one's here. Okay, so we want to do 1 over x squared plus 4. All right, so this one's here. This is x plus a squared, right? So this is a squared. So this will be what? So a is equal to what? A is equal to 2. Okay, so let's go back to check which formula is x squared plus a squared. X squared plus a squared. Oh, so my substitution is a tangent theta. All right. So now I know my x here will be a tangent theta. So what is a? So it's a 2 tangent theta. Right? So this is a 2 tangent theta. And then we know then you can change this, the x over 2 is equal to the tangent theta. See here, and I know the tangent theta is opposite over what? Opposite over adjacent, right? Then for here, you can say this is a dx is equal to the 2 secant square theta d theta here. And now let's try to find, so we need to find what is this square roots here. Of course, you can go back to the formula to kind of reference it. But if you know how to derive it, then you don't really need to remember that, right? Okay, so the tangent is x over 2. So here, this is x over 2. So I know this is the x and this is 2, right? And then by the Pythagorean theory, what is here? Here will be x squared plus what? Plus 4. Arbitrary, right? So it's here, right? So x squared plus 4 here. But because of this is the tangents, right? So the x squared plus 4. So we know the tangent and the secant is always is a pair, right? So they can do the integration. So now let's try to change this one. So this is the secant. So if I do the secant theta is the hypotenuse. So it's x squared plus 4 over 2, right? So I know the x squared plus 4 is equal to the 2 secant theta. See here. So if you do the triangle, then you don't really need to remember like which one's which, and you can just derive this very easily. Okay, so now let's take a look. How do I do this one? So this is 1 over, okay, x squared, right? So remember we need to replace every term. So the x squared is 4 tangent squares, right? Because x is 2 tangent, so it's 4x squared. So what is x squared plus 4? Is 2 secant theta, right? So it's times 2 the secant theta. And what is the dx? Dx is here, so this is 2 secant square theta d theta. If you like, you can do like what we did before. Make sure we cover each term. So this is x squared. So you color code that, right? So this x squared plus 4 is 2 secant theta. And then the last ones here is here, right? 2 secant theta is dx, right? So you know your whole integration was covered, right? Okay, now it's changed to a integration with the trig functions, right? Okay, so now let's simplify it a little bit. So for these ones here, this 2 and 2 I can cancel, and the second I can cancel 1. So here, this is second, I can cancel once here, right? So now I can take this 1/4 out, and then this is the secant theta, and this is a tangent square theta, d thetas, right? Okay, so now this one's here. Let's see here. How do we do the integration? Well, the tangent, if you flip it, so this will be cosine square theta over sine square theta, right? So this is the one. This is 1 over tangent square, right? Tangent 1 over tangent square is a cotangent, so it's a cosine square. And then times the secant is 1 over what? 1 over cosine theta d thetas, right? Okay, now in here, then you can say, oh, that's good. So cosine, I can cancel 1 cosine here. So now we have 1/4. Then this is the cosine theta sine square theta d theta. Then we say, oh, okay, from the previous lecture, so because there's a cosine theta d theta, so I know I can do the u sub, right? So now you do u sub, so you will say u is equal to what? U is equal to the sine theta, right? Now what is the du's here? Du will be equal to the cosine theta d theta. Am I right? Okay, so now the whole thing here, this will be equal to the 1/4. Okay, so now cosine theta d theta is what? Is du. Then what is the denominator? Is u squared. Okay, so now this one is pretty easy to do the integration. So this is the 1/4. And the u to the -2, so it's a -1 u to the -1 plus 6, right? Okay, so in here we can say this is -1/4 u plus 6, right? Okay, so what is the, okay, so now in here -1/4, because we are integrating, so here, take a look, we are integrating x, so we need to change everything back to x, right? Okay, so first I do the u sub here, so this is 1 over u. What is 1 over u here? It's 1 over sine theta. Now what is 1 over sine theta? It's a cosecant theta plus 6, right? But we need to change everything back to the x. Let's see what is the cosecant. So go back to my triangles here. Sine is the opposite of hypotenuse. So cosecant will be what? The hypotenuse over adjacent opposite, right? So what is the final answers here? It will be hypotenuse over opposite. Hypotenuse will be x squared plus 4 over opposite is what? Over x plus c, right? So my final answer will be like this. So remember, right, because you are starting with x, so you need to switch back everything to the x here. Okay, right? Okay, so now let's take a look. This is x squared minus a squared here. Okay, so let's take a look at x squared minus a squared. So what is the substitution? Oh, I need to use the second theta. All right, so let's start here. X squared minus a squared. All right, so I know my substitutions here. Let's try to use the color coding. So x is equal to what? A second theta. Okay, so the x over a, so it's equal to the second theta. We always do the same thing. Then the dx is equal to a second theta tangent theta d thetas, right? Okay, what is the next step? Do a triangle. Right, so this is my angle theta. Okay, so x equal to a seconds here, right? So secant theta is equal to the x over a. Secant theta is equal to the x over a. Secant is hypotenuse over adjacent, right? So it's xa. So like this. Okay, so now by Pythagorean theory, what is here? This is x squared minus a squared, right? Okay, x squared minus a squared, and now we need to change to the, because we know the secant and the tangent is always the partner. So I know the tangent theta here. So what is the tangent theta? It's the opposite over adjacent, right? So it's x squared. Okay, so now I know the tangent theta is equal to the x squared minus a squared. So that's what I have here, right? So, okay, so now I got everything I need, so I can start to switch, right? Okay, x squared minus a squared, x squared minus a squared. What is that? It's a tangent, right? So I have a tangent theta here. All right, then the dx is what? Dx is a secant theta tangent theta d theta, right? Oh, that's good. I can cancel something. Let's see what I can cancel. I can, a and a I can cancel. Tangent and tangent I can cancel. And now this one's here. Okay. Okay, so this one's here will be, here, let's have to draw, okay. Okay, so let me, okay, so this one's here will be, this will just be the integration of what is the secant theta, d theta. And remember, and in our previous lecture number 7, the video number 3, we know how to take the integration of the secant theta, right? So if you still remember, so the answers here, the secant theta, the formula is will be the secant theta plus tangent theta plus c here. And now, okay, because like, remember everything we start with x, so we need to do what? We need to transfer back to the x. Okay, so now let's take a look. So this will be, okay, so the natural log secant theta, right? So take a look at our triangles here. Secant theta, secant is the hypotenuse over adjacent. So secant theta, this will be xa. What is the tangent theta? Tangent is opposite over the adjacent, so this will be x squared minus a squared over a plus c. Okay, so this one is pretty easy here. Okay, now let's take a look. The last one. This one is a little tricky. We need to remember how to do this. Okay, this one's here, we have a square root of 3 minus 2x minus x squared. Then you will say, you know, the formula we have is always like a squared minus x squared or x squared minus a squared. I never have this, like 3 minus 2x minus x squared. what I need to do here. All right, so for this type of the problems here, the first things here, this is your trouble terms, right? This doesn't match the standard form we are looking for. So in here, what you need to do is here, you will need to use a completed square technique. Okay, so you need to use the completed square to change this to the format we recognize here. Okay, so now let's take a look. How do I complete the square? So this is 3 minus 2x minus x squared, right? Okay, so now in the algebra we know that. So you minus here, so this is x squared plus 2x, right? So I just put a parenthesis. Okay, now inside the parenthesis, I can complete the square. So this is x squared plus 2x. What here is a plus 1. All right, so be very careful here, right? So because this is the, right? So it's the plus 1 here, right? So it's a minus 1. You cannot just minus something. So what is here? You need to plus it back. All right, so that's why this is will be 4 minus x squared plus 2x plus 1. So what is the x squared plus 2x plus 1? So this is will be x plus 1 to the square. Wow, that's kind of the, okay, so now it's kind of like the, we finally kind of the similar, like almost reach the format I'm looking for, right? Okay, so now, but still it's not, so I need to, so these things I can change to the 4 minus x plus 1 square. So if this one can be a single variable, then that's good, right? So now I will say, okay, how about then let's do a u sub here. So I will let the u is equal to the x plus 1. All right, then the du is equal to the dx. So what is this one going to change to? Okay, so if u is equal to the x plus 1, what is happening here? So this one's here will be 4 minus u squared, right? Okay, du equal to dx. So here is du, no problems here. This is du here, right? And now, what is x here? U equal to the x plus 1. So x equal to what? Is u minus 1. Yes, right? So we change that. Okay, so now this is the form we are familiar to, 4 minus u squared. Okay, now let's go to take a look of what is a minus x squared. Is a sine theta. Okay, a sine theta. So for this now, so this is a square minus, so this is a square. So what is my a? A is 2, right? So because this is the a is 2, so I know my substitution will be u is equal to what? U will be equal to 2 sine theta. Am I right? And then do the same thing like we did before. U over 2 is equal to the sine theta. Then du is equal to what? 2 cosine theta d theta. Right? Okay, 2 cosine theta d theta. Now let's do the triangle again. Okay, so this is, let's do the triangle. So this is theta. All right, the color coding. U is sine theta equal to u over 2. So it's opposite over hypotenuse. Right, so this is u over 2. And then by the what? By the Pythagorean theory, what is this one's here? This is 4 minus u squared. Right, so if this is a 4 minus u squared, so I know the sine and the cosine, so always is a pair, right? Okay, so now in here I will say the cosine theta is equal to what? 4 minus u squared over what? Over 2. So I will know the square roots of 4 minus u squared is equal to the 2 cosine theta. Okay, now we are in a good shape here. All right, so now this one's here, we're integrating. All right, so now this integrating u minus 1, right? U minus 1. Remember, everything need to be replaced. U minus 1. So this is a 2 sine theta minus 1. All right, u minus 1. So this 2 sine theta minus 1. Let's color code that so we get rid of this is by using this. And 4 minus u squared, the square roots, this one, hey, we just did in here, right? Okay, so that will be 2 cosine theta, right? So this one we replace by here. Then what is the last ones here? We have du's, right? Du is here, is times the 2 cosine theta d thetas, right? So the du is here, so we replace with here. So now after you do that, then you know you did not miss any terms. Now let's take a look. What we can do? Oh, not bad, not bad. This one can cancel, right? So now I have 2 sine theta minus 1 d theta. All right, so now I can say this is a 2 sine theta d theta minus 1 the d theta, right? Okay, so sine integration is negative cosine. So it's a negative 2 cosine theta. What is the d theta? Just the, you know, this is 1 times d theta, right? So this will be just minus what theta, right? Plus c. All right, remember everything need to go back to what x is here. So let's start put it back. So negative 2. Cosine, what is cosine? Adjacent over hypotenuse is negative 2 4 minus u square over what? Over 2. Am I right? All right, so that's good, all right? So now minus, this is what? This is theta, right? So the theta, so the theta's here, I can say this will be, what is the theta? Will be the cosine u over 2, right? I can push the u back. Okay, so plus c. So 2 and the 2 can cancel to simplify a little bit. And okay, so now let's see here. So this will be negative 4 minus u square minus sine cosine u over 2 plus c. Did we finish? No, we're not finished because we start with x. We need to go all the way back to x. So what is u? X plus 1. Okay, last steps here. Now x plus 1. So I need to substitute the x plus 1 back. All right, and minus cosine x plus 1 over 2 plus c. All right, so now you FOIL this one out. This will give you the same thing. So this will be 3 minus 2x minus x squared minus cosine x plus 1 over 2 plus c. All right. All right, so this will be our final answers here. All right, okay. All right, so this is we did 3 problems about how do we use the substitutions, right? The trig substitution. And first 2 problems are pretty straightforward. You just follow the format. And then the third one's here, we need to be a little bit careful, right? So for the problems here, in the numbers inside the square roots is not exactly match the format of our formula. So remember, so what type of the scale we need to know how to do the complete the squares, right? And that's it. So this one's here, really we talk about the trig substitution, and then you need to use the u sub, and then use the trig trig integrals, different techniques we learned from the previous. Okay, so it's a very interesting the techniques and kind of very useful, especially when you deal with those square root things. All right, that's it. And nice talk to you, and looking forward to go over to our next lecture and talk about another integration skills. All right. Okay, talk to you later. Bye.